This is the second video on section 4.8, curvature. So we're going to start by looking at part B of example 109. So our function is 2 cosine t, 2 sine t, 0. Calculate the derivative of our vector value function, and we have negative 2 sine t, 2 cosine t. The magnitude of r prime is 2, and so the unit tangent vector is 1/2 r prime. 1/2 r prime is negative sine t, cosine t, 0. This is the unit tangent vector, so this has to be a unit vector. This is a good place to stop and check your work, right? This should be a unit vector. So then we take its derivative. We have negative cosine t, negative sine t, 0. This also happens to be a unit vector. In general, t prime does not have to be a unit vector. In this case, it is. So now we calculate the curvature. We take the magnitude of t prime of t, divide by the magnitude of r prime of t. We have 1 divided by 2. So our curvature is 1/2. Let's compare this to part A. What does this parameterize? This parameterizes the circle in the xy plane centered at 0, 0 of radius 2. Before, we looked at the circle in the xy plane centered at 0, 0 of radius 1. This is a larger circle. It has smaller curvature. So, and that agrees with our intuition, that larger circles have smaller curvature and smaller circles have larger curvature. Think about the Earth. When you go out and you look outside, it looks flat. So compared to these circles, the Earth is very large. You're not going to see the curvature of the Earth from the ground. Theorem 110 is another way of calculating curvature, just in terms of r and its derivatives. So first we take the cross product of the derivative of r with the second derivative. Remember, a cross product is a vector. Dot product is a number. Cross product is a vector. So we take the magnitude of that vector, that gives us a number, and we divide it by the magnitude of r prime cubed. A way to remember this is sometimes I call this the 1, 2, 3 theorem, because we take the first derivative, we take the second derivative, and down here we're going to cube the magnitude of the first derivative. So 1, 2, 3. So that might be a way for you to remember this formula.